Okay, so I think let's start with the session. So hello everyone and a very good afternoon to all of you joining us from different parts of the world today. And a very warm welcome to all our respected authors and invited guests. So you are now attending technical session 9E. My name is Yashita and I'll be your moderator for this session. I'm truly delighted to be here with all of you and looking forward for a very smooth, engaging and a knowledge packed session together. So, on behalf of the Global Knowledge Research Foundation and GR Scholastic LLP, it gives me great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Competitive Strategies ICTCS 2025. So this year is a very important year for us. It is the 10th edition of ICTCS and it is being conducted in the hybrid mode. So the physical conference was successfully held day before yesterday in Jaipur. And yesterday and tomorrow, which is 16th and 17th, so we were connecting virtually through Zoom. So wherever you're joining us from today, thank you for being a part of this special edition with us. And let's make the most of this digital space together. So we have an excellent lineup of presentations scheduled for this session, covering diverse ideas, research topics, and innovative approaches. I'm sure that you'll find today's discussion very informative and engaging. So even in an online setting, I hope that the exchange of ideas and perspectives will truly bring life to our session today. So before beginning with the session, I'll quickly give an overview of how the session's workflow will be. So we will be having 10 presentations scheduled. Each presenter will be given 10 minutes for the presentation, followed by 2 to 3 minutes for questions and discussions with the session chair. And at the 9 to 10-minute mark, I will give a gentle reminder to the presenters so that it will help them manage the session smoothly. We kindly request all the participants to stay connected with us until the closing remarks. So your presence and engagement will add great value to this session. If you have any questions, clarifications, and updates during the session, please put it in the chat box so that I can assist you accordingly. So before we begin with the paper presentations, it is my pleasure to introduce the session chair for this session, Dr. Sridevi S. Vasekar. She is an assistant professor at at PICT Pune with over 16 years of academic and professional experience. She specializes in electronics and telecommunication and computer engineering. So Dr. Vasekar is committed to advancing technical education, guiding students in emerging technologies, and contributing to research and innovation within her areas of expertise. So, ma'am, we are honored to have you today with us. And we now welcome you to share some welcome remarks with us.
Thank you. Thank you, Yashita ma'am. Okay, good afternoon, everyone. My name is Dr. Sridevi Vasekar. I will be serving as a chairperson for this session. It's my pleasure to welcome you to Virtual 9E as a part of the 10th International Conference of ICTCS 2025. This session brings together a set of presentations that addresses AI, ML, IoT field. This paper reflect both depth and diversity of ongoing work in this field. We are fortunate to have contributions from the researchers as well as the party practitioners representing from the various institutes. We have total 10 presentations uh, scheduled in this session, and each speaker will have 10 minutes, as already Ashita ma'am has explained you, and 2 minutes followed by the 2 minutes for the questions and answers. So I encourage everyone to participate actively during this session. Please keep your answers concise and focused. All the participants are requested to keep your camera on during the presentation. With that, let us begin our session. Over to Yashita ma'am.
Okay, thank you so much, ma'am, for those remarks. So, as ma'am said, we have to make it interactive, guys. You'll have to switch on your cameras for your presentation, please, unless there is any network issue. So, let's move on to the first presentation. So, we have Spurti Ravi Prasad, who will be presenting her work titled as A Multimodal Patient Similarity Graph Framework for Alzheimer's Disease Diagnosis. So, Spurti, are you ready with the presentation?
Yes, ma'am. Ma'am, is it okay if I like switch off the camera? Like there's a little network issue.
Yes, yes, sure. Sure, sure. You can begin your presentation. I'll stop sharing my screen.
Okay.
Yes. Spurti, just keep in mind you have 10 minutes. You have to present your idea within 10 minutes.
Okay.
Yes, you can begin.
Good afternoon, everyone. I'm Spurti. I have my teammate Sia here.
Good afternoon, ma'am. Myself, Sia.
Today we'll be presenting our work titled Multimodal Patient Similarity Graph Framework for Alzheimer's Disease Diagnosis. I'll give a brief introduction. Alzheimer's disease is a main cause for dementia worldwide, and its diagnosis is challenging due to a strong patient to patient variability. Most existing approaches, including multimodal deep learning models, treat patients independently, ignoring the relationships between similar patients. Based on that, we came up with our problem definition. The problem definition is that current multimodal models achieve good accuracy, but they treat patients in isolation. So, ignoring these hides the shared symptoms pattern, and then it causes a wrong decision on the disease progression. So, modeling these relationships can improve Alzheimer's diagnosis and enable meaningful patient subtyping. We tried to research some of the papers, and I have briefly listed them here in the slide. So, current multimodal models, as I already said, they take the patients independently. So, explicitly modeling these relationships will be our main focus. I've already discussed the research gaps. Coming to the objectives, so the objectives in a very brief way, we plan to construct a patient similarity network, and then we develop a hybrid embeddings for them, which includes the MRI node vectors and also the clinical data. And then we perform unsupervised patient subtyping, which includes k-means clustering. And then we finally train a graph attention network. So this is the methodology. First, we have chosen the data from OASIS 1 dataset, and then we also augmented it with synthetic patients data. So, clinical details for these synthetic data like age, education, clinical dementia rating, many mental state estimation, all of these were generated using Tiny Llama. And then the MRI features, we generated that for the synthetic data using sampling methods. And then to ensure that these synthetic data is realistic, we try to check the value ranges of these with the real patients which we had. And then finally, we finalize the data set. The MRI images cannot be used directly in the graph, so we try to convert that into numerical vectors. And once the MRI vectors were created, we combined it with the clinical features, as I said before, and we applied a principal component analysis. So principal component analysis is a method where we reduce the noise present in the data set. And then finally, we used cosine similarity to construct a patient similarity network. Where each node denotes a patient, and the edges between them is formed based on the cosine similarity. So higher cosine similarity, edges are formed. And then each patient is connected to at most like five similar neighbors. So this was the thing. And then finally, we used the k-means clustering method to form groups of patients here. So each of the group showed a disease subtype, the possible disease subtype. So this helps the doctors figure out which patients are closely linked, so they can easily diagnose and like carry on the treatment procedure. So finally, we trained a graph attention network, and this helped us to predict the patients with various severity levels. I would like to show the patient similarity network here. So here in this image, you can see nodes colored in 4 different colors. So the purple nodes are those which represent the patients with the least affected Alzheimer's case. The yellow node represent the patients with advanced or severe Alzheimer's. The green nodes represent the patient with moderate disease severity, and the blue ones represent the patients with mild or early stage symptoms. Then these are the results we obtained. So here we try to construct k-means, using k-means clustering, we determine 3 different clusters. So the cluster 1 shows entirely normal group. So here, as you can see, it's the blue color, it's the orange one. So you can see there are a significant number of them. Again, this is just a sample. We had trained on 200 patients. Then cluster 0 showed mild or mostly like they had noticeable cognitive decline, sorry. So it is the green one, and the cluster 2 showed the immediate stage. So this shows applying k-means clustering could actually help us discover the subtypes. And this is the result of the GAT classification. After training on the data set, we obtained a final accuracy of 97%. When compared to other approaches like MADI and FusionNet, which is based on our literature review, they had their accuracies ranging from 96 to 94. So this shows that our work has a higher accuracy. But again, here we have trained on a very limited data set, like about 200 patients. So we plan to improve this in our future work. And then also the node vectors that were generated and the patient similarity network, again, we can improve it based on, the future work. So that we plan. And yeah, that was the presentation. Thank you.
Okay, ma'am, do you have any questions regarding this?
Yes. Okay. Please, can you explain me what are the major challenges in the Alzheimer's disease diagnosis? Major
Ma'am,
challenges.
so the first thing is Alzheimer's disease is basically like it depends on multiple factors. So what happens is when the doctors are trying to predict it, it's really difficult to predict in the early stage. So that is the major problem with Alzheimer's. So we try to get some of the data from OASIS patients, and we try to use some features like the age, and then the mild the clinical dementia results and other things. So we try to incorporate as much as possible, but still there is scope of improvement in this. We can still make it in the future scope.
Okay. One more question. What classification model is used and why?
We used for the clustering purpose, we used k-means clustering, because here we cannot determine exact number of, exact subtypes. So we gave the model the liberty to determine the subtypes based on the inputs given. And then finally, we used the graph attention network because the Alzheimer patients, the disease is basically linked to the diagnosis can be actually done when we link it to multiple patients rather than individually. So graph plays a major role, and attention mechanism is used because we want to select those nodes that have the most importance here, not the nodes which are least important to that particular patient. So that's why we planned on this approach.
Okay. Okay. Over to Ashita ma'am.
Okay, thank you so much, Purti, for sharing your idea. Now, the next presenter, we have Albin Joshua to present the paper titled as AI-powered Indian medicinal plant identification and Indian computer vision technology. So, Albin, are you present in the meeting?
Yes, ma'am. Yes, ma'am. Is my voice is audible, ma'am?
It is cracking a bit. Can you resolve the network issue?
Okay, ma'am. 1 minute.
Yes, you can first share the screen and then check if it is visible and the voice is clear or not.
Okay, ma'am.
Yes.
Actually, it shows multiple screens cannot be shared at a time, ma'am.
Yes, I've stopped my screen sharing.
Oh, okay, ma'am. Now it's clear.
Yeah.
Is my screen visible, ma'am?
Yes, yes, you can begin.
How is my voice audible, ma'am?
Yes.
Okay, ma'am. Mm, Good afternoon, everyone. I'm Albin Joshua, and today I'll be presenting a research titled AI-powered Indian medicinal plant identification and information system using deep learning and computer vision technology. This work focuses on how artificial intelligence can help digitize, preserve, and safely use India's medicinal plant knowledge, which is still largely undocumented and difficult to access in real-world conditions. Coming to the introduction part, India is home to one of the richest collection of medicinal plants in the world. These plants form the backbone of traditional systems like Ayurveda, Siddha, and Unani. In fact, nearly 80% of the global population relies on plant-based medicine in some form. Because of this, accurate plant identification is not just a technical problem, but also a matter of public safety and culture preservation. In our work, we explore how deep learning and computer vision can automate this visually complex task and make medicinal knowledge easily accessible. Now, coming to the problem statement. Despite the importance of medicinal plants, identifying them correctly is still a major challenge. Manual identification is slow, expert dependent, and are still error prone, especially when different species look very similar. Many existing digital tools either focus on foreign plant species or provide only name without any safety related context. This creates a gap between plant recognition and practical real world usage, especially in field conditions. Coming to the part of the objective, with this motivation, we set the following objectives. First, to build a highly accuracy classification system specifically for Indian medicinal plants. Second, to compare two efficient deep learning models. Those are ResNet 18 and EfficientNet B0. Third is to integrate the visual prediction with an LLM-based knowledge retrieval system. Finally, we aim to deploy everything as a scalable, low-latency web application suitable for real-time use. Coming to the related work, earlier research used CNN architectures such as AlexNet, VGG, and ResNet for plant identification with reasonable accuracy. However, many systems work only on clean leaf images and fail under real-world conditions. Some approaches depend on handcrafted features which limit classification accuracy compared to deep learning models. Recent studies explore Bayesian-based analysis, ensemble techniques, and multimodal approaches. Although LLMs are emerging for urban information retrieval, they are rarely integrated directly with CNN prediction pipelines. Existing apps like PlatNet and LeafSnap lack optimization for Indian medicinal plant diversity, highlighting the need for an integrated real-time solution. Now, coming to the proposed system overview part, it is a multimodal framework. It doesn't just recognize a plant image, it understands what the plant is, what it's used for, and what precautions should be taken. By combining CNN-based visual feature extraction with an automated knowledge retrieval block, we provided a single platform for identification and education. We used highly quality images collected from Kaggle and academic repositories covering leaves, plant, stems, flowers, and whole plants. Then all the images are resized to 224 by 224 pixels, normalized and augmented using techniques like flipping and zooming. These steps help the model to handle real-world variations such as lighting changes and background noise. This pre-processing ensured a robust and balanced dataset. Now coming to the model architecture, we selected two CNN architectures for comparison. ResNet 18 was chosen for its lightweight residual connections and fast inference speed. Then efficient net D0 was chosen for its compound scaling, which improves accuracy without increasing model size. Both models were pre-trained on ImageNet, allowing them to learn basic visual patterns before being fine-tuned on Indian medicinal plant images. Once the plant is identified, the predicted label becomes a key for our JSON-based knowledge base. This database contains medicinal use, phytochemical properties, and precautionary guidelines. To make the information user-friendly, we use Google Journey, which dynamically generates structured and easy to understand explanations. This ensures that even a non-expert user can safely interpret the output. This slide shows the end-to-end workflow. First, the CNN performs visual recognition, then the predicted label is converted into a structured JSON query for the LLM. The LLM generates context-aware information such as dosage in search safety warnings. The entire pipeline completes in under 200 milliseconds, making it suitable for real-time field use. Then this slide shows the performance results of the two models that we have chosen. Our result shows a clear difference between the two models. This shows the numerical value of the image provided before. While ResNet 18 is faster, EfficientNet B0 achieved a higher accuracy of 90.3%. Also performed better in terms of precision, recall, and F1 score. This indicates that EfficientNet B0 is more effective at handling fine-grained differences between visually similar plant species. The front end of the system is built using Streamlit, which provides a clean and intuitive interface. The back end is containerized using Docker and deployed on AWS EC2. This makes the system portable, scalable, and capable of handling higher demand during field research or academic use. Speed is critical for real-world usage. ResNet 18 achieved an inference time of 150 milliseconds, while EfficientNet B0 took 175 milliseconds. Both models deliver a smooth and responsive user experience, even on mid-range devices. Coming to the error analysis part, from the confusion matrix, we observed occasional misclassification between species like aloe vera and basil. These errors mainly occur due to similar leaf shape and challenging lighting conditions. This analysis highlights the scope for more advanced feature extraction technique in future versions. Coming to the system features, the key features of our system include real-time plant identification, automated medicinal knowledge delivery using LLMs, cloud-ready and scalable architecture, easy usability for non-expert users. This makes traditional herbal knowledge accessible beyond experts. Coming to the advantages of the proposed system, the major strength of the system is the synergy between vision and language. Unlike standard plant identification apps, our system provides evidence-based medicinal utilities and contradictions. In essence, it brings the combined knowledge of a botanist and a pharmacist into a single platform. Coming to the limitations part, we also acknowledge certain limitations. Currently, the dataset includes 50 medicinal plant species. The LLM's full capability depend on internet connectivity, and very low quality images can still affect accuracy. These limitations guide our future improvements. Coming to the part of the future enhancement, going forward, we plan to expand the dataset to thousands of regional plant species. We also aim to add multilingual support for Indian languages, develop dedicated mobile application, and explore vision transformers for improved performance. To conclude, we have developed a multi-model AI system that identifies medicinal plants and provides critical information in real time. This work bridges the gap between AI and traditional herbal science, contributing to the digital preservation of India's medicinal heritage. Thank you for the time. I'll be happy to answer any questions there, ma'am.
Okay. What is significance of combining the CNN and with LLM? What is significance of combining CNN with LLM?
Sorry for the inconvenience, ma'am. Your voice is breaking.
Hello.
Am I audible, ma'am?
Yeah, you are audible.
Yes, ma'am. Yes, ma'am. Now I'm audible. Now I can hear your voice, ma'am.
What is the significance of combining CNN with LLM?
Significance of combining CNN with LLM. Okay.
Yeah.
The main significance of combining CNN with an LLM is that, ma'am, each model complements their usage. The important part of CNN focus on visual understanding, ma'am. It looks at the plant image and accurately identifies the species based on shape, texture, and pattern. On the other hand, the LLM focuses on context and knowledge. Once the plant is identified, the LLM converts that label into meaningful information, like medicinal use or any other phytochemical, ma'am. So by combining them, the system doesn't just say what the plant is, but it explains why it matters and how safely the plant can be used.
Okay. Over to Ishita, ma'am.
Okay, thank you so much, Albin. So next we have Gayatri GR to present her work titled as an AI and IoT driven framework for rain-aware quality inspection of post-harvest paddy. So Gayatri, are you ready with the presentation?
Good evening, ma'am. I'm
Good
ready, ma'am.
evening. Yes, you can share your screen, please. Everybody who has done with the presentations, please stay with us at the end of the till the end of the session, as there are a few
Is it visible,
updates to
ma'am?
give. Yes, yes, it is visible.
Mm.
You can start.
Good evening to all. I am Dr. G.R. Gayatri, myself and Dr. K. Revati presenting this paper. As we all know, Tanjavur is the granary of Tamil Nadu, and it is also called as the rice bowl. So I have taken the problems of the small landholders, and in that problem, I have specifically analyzed what are the problems they face after harvesting the paddy in quality and quantity losses. So the basic problem I have taken is the moisture management. Even though there are many studies in moisture management, here in my study, I have taken how the edge computing and IoT things are helpful for analyze the problems of the small farmers. The basic objective of our study is to design and develop a low-cost IoT-based system for monitoring the post-harvest paddy moisture. And the second objective is Edge AI-driven classification model, development and implementation of the Edge AI-driven classification model for the dry, moist, and wet state of lands. We have classified the lands as wet, dry, moist, and wet state. And then the third objective is to create aware intelligence of using real-time weather data. And last is they validate a system through the simulation and field deployment and demonstrate the improved accuracy, reliability, and practicability to the small farmers. And this is our review of literature. For that study, we have gone through many studies of the different authors and institutions. So based on that review of literature, the research gap we have found is classified into three. One is relating to the context aware moisture assessment. That is how the IoT things are used for the moisture level to check the moisture level of paddy. And second is we have found is there are only limited studies in the edge AI field. And third is the gap to find out the gap between the laboratory accuracy and the practical deployment. This study was very helpful to us. So we have provided two solutions through this study. One is the integrated IoT and edge AI framework. We have combined these two, and because with or without internet, the farmers can find the moisture level in the paddy. For that purpose, we have integrated the IoT and the edge AI framework. And then the proposed system, we have implementing our study in four levels. For that, we have developed a proposed system architecture. So the proposed level architecture consists of four layers like sensing and edge hardware layer, intelligence and processing layer, raw data stream layer, cloud and application layer. So this is presented in the diagram also. So from this image, we can understand first we will implement and use some sensor like moisture sensor, temperature sensor and humidity sensor to analyze the data. And the data will be processed using microcontrollers and IoT. And then we will give solution to the farmers for their problem. And we will apply in the practical world. For this, we have given some specification also. So the moist sensor, temperature sensor, humidity sensor, what are the things we are using for that? We have given some specification. And then this is our methodology for implementation. And here the first we will collect the data, curate the data using the sensor, and then we will develop. We have developed a prototype model, and based on the prototype model we can give a solution to the farmers for their problem relating to post harvest, especially the moisture level. And then this is the data what we have taken through the pandas, matplotlib and numpy. So from these sources we have collected data. Based on the data only we have done the work. And here this is the data set. In this data set we can find that the dry land majorly we have covered, and then wet and moist land also. Proportionately we have collected data from all these types of lands. In the data here also we can find that the paddy moisture data set shows that the wet land is very low. And from this moisture and humidity cases, temperature and humidity cases, moist is spreaded equally in all the places. So the confusion matrix also shows that the diagonal, that is the capacitive reading, or the correlation is positive in the matrix. We have taken a valid data. This shows through these diagrams. And this also shows the accuracy of our data. Three machine learning models we have trained. The machine learning model trained or the random forest, gradient boosting and neural network. So these three models were used in our study. Among these models, random forest is considered as the best one because it has provided a best result for our study. This is given in the model performance and analysis. So through the model performance and analysis, we can understand that the random forest is the random forest shows the best model. And among these models, the capacitive reader is a dominated one. And neural networks shows that the bias is reducing because of the random forest result. And then the IoT data streaming simulation is
Gayatri, your
given here.
voice is
In
cracking a
this,
little
we
bit.
have taken 15 simulation, and all the 15 simulation have provided a good result without any error. And finally, what we want to conclude, using this proposed system, the farmers can easily classify the land, and they can find the moisture level at a good level. So it will be helpful for the farmers to solve the problem relating to moisture. and future work also possible from after this study. So they can take field validation with the real paddy sampling, and then we can use scalable hardware and a decision logic framework through this study. And after this study, in the future, we can also long range lower power communication technologies can also used. So these are the possibilities in the future. Thank you. That's all my presentation.
Okay. Can you tell me why is this
Sorry,
system?
ma'am, I can't hear you.
Hello? Hello? Am I
One
audible?
second, ma'am.
Gayatri, you can stop sharing your screen so that your internet connection will work better.
Yes, ma'am.
Am I
You
audible?
can stop
Yes,
sharing your
yes.
screen.
Yes,
Okay,
yes.
yes. Hmm. You can ask a question, ma'am.
Okay. Why is this system considered low cost and scalable?
Because ma'am, farmers they are spending a lot in, especially in South India. Many farmers are marginalized level only. They have very small size of land. They can't spend much for the technology, and even many farmers they don't have internet facilities also. So that it is necessary to give technology at low cost.
Okay. One more question.
Yes, ma'am.
What benefits does Edge AI provide over the cloud only AI?
Ma'am, without internet also they can use the edge AI, ma'am, so that they can make technology at low cost.
Okay.
Thank you, ma'am.
What to Ishita ma'am?
Okay. Thank you so much, Gayatri, for sharing your work. So, our next presenter is Adarsh Gupta to
Thank you,
present
ma'am.
their work titled An Efficient Machine Learning Based Approach for Fault Sensor Node Detection in WSNs. So, Adarsh,
Yeah,
are you ready with the presentation?
yeah, I'm willing.
Yes, you can share, please.
Yeah, just a second. Yeah, screen visible?
Yes.
Yeah. So, hi guys, my name is Adarsh, and my topic is an efficient machine learning based approach for fault sensor WSN, that is called wireless sensor networks. Coming to the introduction part, what is wireless sensor networks are? It generally consists of various numerous sensor nodes that collect, process, and transmit data wirelessly, and often deployed in the remote and challenging environment. Coming to the application of WSN, it can be used in environmental monitoring, healthcare monitoring system, smart cities, and military and surveillance systems. And objective is basically here to use is the machine learning based approach to detect a faulty node that is efficient enough. Uh, Coming to next slide, faulty sensor node consequences. Now, what is fault node sensor and what is fault sensor node? It's generally produce the incorrect data and stop functioning properly. And maybe it can be caused by hardware failure or battery depletion, noise, or the attacks. And consequences faced for the fault node are like loss of data transmission, inaccuracy, and increased network traffic, and security threats like DDoS, and reduced network timeline and performance. Challenges in wireless sensor networks. First is the manual detection. Like manually identifying the sensors is often impractical due to large scales and distributed nature of wireless sensor networks. And second is the complexity. It's much complicated by the factors such as limited communication bandwidth and power constraints and diverse sensor types. What motivates me to use a machine learning is it generally automates the faulty detection and also improves the accuracy. Machine learning also offers a automated solution for identifying the sensor and reducing human intervention and improving efficiency, which also gives the better accuracy. So yeah, in this, I've used 5 machine learning algorithms. First is the logistic regression, which is a linear model for binary classification. Second is the support vector machine, that is called SVM. It's a powerful algorithm for finding the optimal hyperpath to separate data points. Third is the KNN it's a non-parametric proximities to known neighbors. Coming to fourth is decision tree. It's a tree-like structure that partition data based on the features and make predictions. And last is the random forest, and it's an assemble machine learning method that combines multiple decision trees to improve the accuracy and prevent overfitting. I am methodology I've used is first is the data collection. Second is the uh, data pre-processing. Third is the EDA, that is exploratory data analysis, relationship between the features and identify the features important. Fourth is the test and train split, where we have just divided the training data into 80 and testing data into the 30 the performance evaluation. And for last step is model development and model evaluation. Coming to the data set, we have generally downloaded the data set from the Kaggle, which is known as famous data, that is EDA WSN data set. And it generally consists of over 10,000 sensor readings for the from the varieties of sensor node deployed in the representative WSN test bed. And pre-processing steps generally underwent the processing to handle the missing values outliers and to normalize the features like sensor data, battery life, and temperature for consistent scaling. Here, the comparative analysis is done based on the all 5 algorithms, where the random forest and the decision tree gives the better accuracy, and rest were bit that were like not good enough. So generally considered the decision tree and the random forest as better accuracy. But decision tree came out the better accuracy. So generally check there might be a condition for overfitting too. So coming to possibilities of overfitting, so check that case of overfitting where I came to know that the training and test accuracy was similar, so there was no possibility of overfitting here. And yeah, so and what analysis here is the higher training accuracy is 100% and slight drop in the test accuracy, which this shows the minimal possibilities of overfitting here and over under control in this case. Coming to conclusion, so decision tree achieved the highest accuracy, that is 98.595%, and whereas the random forest was 97.95, which is often preferred in the practical scenarios due to robust and ability to reduce overfitting. So here the conclusion is that decision tree is most accurate model for the data set, and but our final choice should balance accuracy, generalized, and overfitting concerns. Future work here is that we can just implement and just we can interact with the advanced algorithm, that is implementing deep learning and reinforcement learning for the better false detection. And real-time fault detection can also be done here, like developing adaptive system for continuous monitoring. And then comes the optimized data pre-processing, improving the efficiency in the handling large data set, and that's through the edge computing. And fourth is the scalability. We can just scalable the solution for the large and dynamic sensor node. And that's all. Thank you.
Okay. What is the data size?
Sorry?
Size of the data. What is the size of the data?
Yeah, 10,000 generally it has the 10,000 rows.
Okay. Can you
Yeah.
explain why feature scaling and encoding are essential in training
Features.
ML models? Hello.
First is, yeah, hello.
Can you explain why feature scaling and encoding are essential in training ML models?
Scaling generally ensures that all numeric features and preventing bias towards the larger values, while whereas the encoding converts the categorical data into the numerical form so that the machine learning models can process and learn from it efficiently.
Okay.
Yeah.
And
Okay, thank you so much.
yeah,
Okay.
Yeah.
Uh,
Thank you.
so our next presenter is Revati K to present their work titled An Integrated IoT and Edge AI Framework for Autonomous Agricultural Irrigation and Real-Time Plant Disease Diagnostics. So Revati, hello.
Yes, ma'am.
Yes, you can
Ma'am,
start.
and that screen should be closed.
Yes.
I'm not able to open this. Yeah, ma'am.
Yes. Yes.
Is it visible now, ma'am?
No, not yet.
Wait a minute, ma'am. I will share.
Yes.
Start to share. Wait a minute. Am I visible now, ma'am?
Yes,
My
it is
present.
visible. You can begin
Yeah.
with the graph.
Good afternoon, ma'am. Myself, Revati, and along with me, Gayatri is there. And our presentation title is An Integrated IoT and Edge AI Framework for Autonomous Agriculture Irrigation and Real-Time Plant Disease Diagnostics. And this is my presentation outline. So initially we want to discuss why these things are necessary, why we want to choose this work and related research review, and then proposed architecture algorithm, why we have chosen edge AI, and what are the things we have obtained from that one, how the plant diseases are inspected, and according to that how the irrigations are controlled. So likewise we want to discuss along with our results now. So this is my motivation. So here, normally, all the agriculture systems are separately doing these things, either in irrigation control as well as this disease detection control. But we want to incorporate both the things, and because of a lot of sensor network nowadays, the clouds are getting crowded. So sometimes we may get some slow. Data also. So because of that, what we think to include in our work means edge AI we have incorporated, and we can do this work in a real time for a locally generated thing. And the problem statement, as I said earlier, so we want to incorporate irrigation as well as our disease detection. So by doing like this, what we can do means we can save the, because water is a scarce resource now, so we can reduce the water scarcity. And as well as we are going to incorporate some AI algorithms in that. So first of all, it will detect the diseases present in the plant. According to that, irrigation will be controlled, ma'am. So after finding lot of literature review in this, we found that we have worked separately based on IoT and separately on Edge AI. They didn't combine both of the things. So we plan to develop an integrated IoT, including with the Edge AI system for real-time monitoring. This will control both the things. This is the summary of the research gap we identified, ma'am. So, yeah, so as I said earlier, you see here the irrigation automation only is there, or else disease detection is only is there, but not both the things are there. We have integrated both the thing, and lot of adaptive here. After finding the disease, we can use some pesticides also to control the diseases. So that adaptation also we can do. So that kind of management we can do along with our work. So limited edge AI development only is there in according to this work. So this is our proposed solution for our issues, open issues. So we have incorporated both the thing, integrated IoT as well as a edge AI system. So real-time sensing we can do, and we can control the irrigation also after detecting the disease from the leaves. So we can control the disease also. So because of edge AI, we can do some local data analysis also. So with or without internet, no internet issues are there here. So we can do the work. So this is our system architecture, which consists 3 layers. So here some sensors will be there, which is used to measure the moisture level. So we used soil sensor, temperature sensors, and humidity sensors to measure all those things. Here, the edge AI is used to find the disease. First of all, present in the leaf. Then, according to that, autonomous irrigation will be deployed by the AA system. So, if you want to get some increase the range distance, then we can go with some cloud uploading and all with the help of some satellite images also. So, but nowadays we did this thing only for local distance. So these are all the types of sensors we used. This is for some ideas we depicted here. This is the specifications of our sensors used in our work. And we used a YOLO model here to take a picture of our leaf to find the disease present in the plant. So this output explains clearly that so we have early bed and a leaf spot disease detection. That and all we can capture clearly with the help of this advanced YOLO V8 model. And here we can see the model, cognitive model. That means automatically the system will be adapted. First of all, the camera will sense the picture of the plant and check whether any diseases are present or not. Depends upon the thing, the model will be, here you see when the disease is detected, some pesticide will be sprayed on that particular spot to remove the diseases. So or else it will continue its normal operations. So here the depends upon the disease detection, the soil moisturization for some of the thing will be poorly get affected when the soil moisture is increasing a lot. So during that time we want to stop the irrigation system. So we want to check that thing. So if the current moisture is less than that level means, then we want to switch on the water pump. The water will be glowing. Otherwise, the soil moisturization sensor again will search its work. So according to our result of here we can prove that the traditional system and compared to the traditional system, our proposed system nearly saves 35 percentage of water savings. So this is the method to calculate the water saving by using our proposed method. So not only the water saving, here we can detect the disease in earlier stage and we can provide some pesticides also to control the disease. So we can prevent the losses of the and these are all the applications we can do with the help of our proposed system. So we can provide some smart agriculture, greenhouse greenhouse farming also we can use. So these are all some of the applications, and this is my conclusion. So with the help of this new technologies, so we can bring a greener future. So here we have considered only tomato. So this thing we can implement for some other crop like paddy, wheat also. So on local data, instead of considering local data, we can consider some other long distance data also. We can get images from satellites also. So we can increase the small scale system into large scale system. These are all the references. Thank you, ma'am.
Okay, good.
Thank you.
YOLO 8 is used for the disease detection. What challenges arise in deploying such a vision model on edge hardware and how were they addressed?
Ma'am, once again repeat, ma'am, please, ma'am.
Yes. You
Yes,
have
ma'am.
used YOLO 8 is used for the disease detection.
Yeah, ma'am.
So what challenges arise in deploying such a vision model on edge hardware? How were they addressed?
No, ma'am. We used YOLO model for taking only the image samples, ma'am.
Okay.
So small scale object detection only we can do with the help of this YOLO model, ma'am. And for large label data set, we may not use this thing.
Okay. And what future advancement could enhance the capability of the proposed IoT Edge AI system?
Ma'am, still we did only for local field and local data only, ma'am. So globally we can increase this by incorporating some wireless sensor networks also.
Okay. Over to Ishita, ma'am.
Okay, thank you so much, Revati.
Thank you, ma'am. Thank you.
So next I invite Janolin Esther S. to present her paper titled as Extended Reality in Agritech, a systematic exploration of XR integration in agriculture. So Janolin, are you here?
Yes, ma'am.
Yes, you can share your screen.
Okay, ma'am. Is my screen visible?
Yes, it is visible. You can start.
Mm. The problem statement that I have found is the agriculture today is under significant pressure due to rapid growth, population growth, climatic change, and limitation of natural resources. These factors demand higher productivity while still maintaining sustainability. The traditional farming practices depend on manual estimation and fragmented data sources, which results in efficient estimation and resources such as water and fertilizers also cause delays in decision making. The technologies like artificial intelligence and IoT are introduced, but the farmers still lack intuitive, real time, and context aware visualization tools which can help them understand and act on complex data efficiently. The more existing extended reality solutions are expensive and complex, which restricts their widespread adoption. Hence, these practices are need to be made updation accordingly. The objective of the research is to systematically analyze the role of extended reality technologies, specifically AR, VR, and MR in modern agricultural practices. The aim is to classify existing XR applications in agriculture into three main categories: precision farming, education and training, and remote assistance. The classification helps in understanding where XR provides the most practical value. The objective is to identify both the benefits and the limitations of current XR based agricultural solutions, especially in terms of cost, usability, and accessibility. Based on these observations, we propose the design of a low cost web AR based prototype called the Agri AR Assistant, which is intended to support real time field operations. Um, the methodology of the research begins with an extensive literature review and systematic analysis. We reviewed recent research articles, survey papers, and case studies to understand the current state of extended reality technologies and how they are applied in the agriculture. Based on this analysis, XR applications were classified into major use case categories. The precision farming and field operation, where XR supports tasks such as crop monitoring, resource management. The second category is education and training, which focuses on immersive learning for farmers and agricultural students. The third category is remote assistance and collaboration, enabling experts to guide field workers in real time. Following this classification, a system justification and gap analysis was performed. We identified key limitations in existing solutions, including high cost, heavy hardware dependency, poor usability, and limited accessibility as well. The architecture is of a client-server approach. On the left-hand side is of the server side, where on the right-hand side is of the client side. Um, on the client side, the web AR interface runs directly on the standard smartphones or tablets using a web browser. It leverages the WebXR technologies to support localization and mapping surface and ground plane detection. On the server side, the cloud-based backend is used to store GIS data, field boundaries, and historical farm records. The AI-based crop disease and pest identification is also been identified here. The key features of the system include parallel line guidance to improve accuracy during planting and tilting, AI-enhanced overlays for crop health and pest detection, and the ability to operate without installing dedicated applications or using extensive XR hardware. The evaluation that are performed here are precision error measures, the derivation from the target crop rows, time to time completion evaluates how long a task takes to finish, the system usability score access users experience and ease of use. Finally, the resource use stimulation estimates the potential reduction in seeds, fertilizers, and water usage achieved through XR assisted guidance. The experimental results are demonstrate the effectiveness of the XR assisted farming approach. When compared with the traditional farming methods, the use of web AI significantly reduced precision errors during field operations, indicating improved accuracy in tasks such as planting and tilling. The system usability score results in were consistently high, which indicates that the web AR interface is intuitive, easy to use, and well accepted by the real field conditions. Additionally, the resource usage stimulations revealed notable reduction in the use of seeds, fertilizers, and water. These findings strongly support the role of XR assisted systems in promoting sustainable and resource efficient agricultural practices. Uh, to conclude, this study demonstrates that extended reality technologies have strong potential to transform agriculture by improving precision, operational efficiency, training effectiveness, and overall sustainability. The systematic analysis of XR applications and the proposed Agri-AR assistant. This research shows how a web AR-based approach can effectively overcome the cost and accessibility limitations of traditional XR systems. As future work, we plan to focus on real-world field deployment, enabling offline functionality, improving localization accuracy, and conducting long-term economic impact analysis as well. Thank you, ma'am.
Okay. Can you explain me how does this XR contribute to precision farming beyond traditional digital tools?
Ma'am, can you repeat the question, please?
How does XR contribute to precision farming beyond traditional digital tools?
For example, when I take a GPS-based farming, the XR guidance significantly improves visual precision at short-range operations. While GPS systems are effective for large-scale mechanized farming, XR-based visuals overlays help reduce human alignment errors during manual or semi-mechanized tasks such as planting and tilling.
Okay. And what are the research opportunity remain for the XR-based agriculture systems?
Currently, people are using based on the cameras of cameras and the edges of the particular field and the scanning of the particular plant. So to detect diseases and how much irrigation it requires as well. And our proposed solution requires a camera of higher quality and a better internet connectivity. Hence, it can produce better results.
Okay, over to Yashita.
Okay, thank you so much for presenting.
Thank
So the next presenter is Ekta Singh to present her paper titled Loan Default Prediction and Borrower Segmentation with Explainable AI. I see there are lots of topics around AI in this session. So, Ekta, are you there in the meeting?
Yes.
Yes, you can present, please.
Is my screen visible?
Yes, it is visible. You can start.
Okay, so good evening, respected chairs and all the participants. I am Ekta Singh from the Department of Data Science and Engineering, Manipal University, Jaipur. Today, I will be presenting our paper titled Loan Default Prediction with and Borrower Segmentation with Explainable AI, co-author with Chirag Joshi. After the COVID-19 pandemic, financial institutions have seen a significant rise in loan defaults. To handle large-scale borrower data, banks increasingly rely on machine learning models. However, most high-performing machine learning models behave like black boxes, meaning they give predictions but no clear reasoning. This lack of transparency raises fairness, accountability, and regularity concerns, especially in credit risk decisions. The objectives of this work are threefold. First, to accurately predict loan defaults using ensemble machine learning models. Second, to explain model decisions using SHAP explainable AI. And lastly, to segment borrowers into recovery-based groups to assess post-default decision making. So we move from prediction, explanation, and then action. We use the Kaggle loan default dataset consisting of approximately 50,000 borrower records. The dataset includes features such as income, credit score, loan amount, employment type, and repayment history. Borrowers were labeled as defaulters or non-defaulters based on their missed payments. The data required extensive preprocessing. Missing numerical values were imputed using median and categorical values using mode. Outliers were treated using IQR to avoid extreme biases. We engineered financial ratio features such as debit to income ratio, credit to loan ratio, and loan to income ratio. We used feature engineering as ratio as it captures financial stress better than raw values. Since default cases were unrepresented, we applied SWOT to balance the data set. We removed the redundant information. We used Pearson correlation for numerical features and Kramer's for categorical ones. Finally, recursive feature elimination was used to select the top 12 most informative predictors. We selected assemble models due to their ability to capture complex nonlinear borrower behavior. The models used were random forest, reduces variances using bagging, XGBoost, boosting based, highly optimized and regularized, and CATBoost handles categorical features effectively. To overcome the black box nature of assemble models, we applied Shapley additive explanation. SHAP assigns a contribution value to each feature based on the game theory, explaining both global behavior of overall model, local behavior, individual prediction. To translate predictions into recovery action, we cluster borrower using mini batch K-means on SHAP values. Based on silhouette value, we selected K as three clusters: data, high recovery, medium risk, and low recovery. Among the models, XGBoost achieved the highest accuracy of 0.91, indicating strong discrimination ability. Borrower segmentation enables cluster-specific recovery strategies such as incentives for low-risk borrowers, OTS programs for medium-risk borrowers, and restructuring for high-risk borrowers. Overall, this framework demonstrates that AI can be both accurate and ethical, aligning with the RBI and UI/AI regulations. Thank you.
Can you tell me why is the borrower segmentation is important?
Borrower segmentation is important because because it helps to differentiate between the defaulters us and non-defaulters, and the defaulters as labeled as risky defaulters, which have not been touched till yet.
Okay. And why ensemble methods are better suited for loan default prediction as compared to the linear models?
Assemble model suited the most because as it takes the combine the weak prediction and make one strong prediction, while the linear one only it's very complex to use it in the complex data as it has 50,000 old defaulters data.
Okay. And what is exact role does play by the SHARP in this framework?
Uh, it's actually classifies of the distributes the distribute the contribution of uh, each and every I guess what we say each and every loan how much loan payment is involved for to make a borrower as defaulter, how much income money is important to categorize as defaulter, or the loan payment missed payment and all to categorize the global the contribution prediction.
Okay. Over to Ashita. Thank you, Ekta.
Thank you, ma'am.
Sorry, there was a network issue at my side. Mm. Okay, so the next presenter is Jatin Tiwari, who's going to discuss the topic real-time AI-powered intrusion detection and prevention system IDPS, a practical implementation using machine learning. So, Jatin, are you ready?
Yes, ma'am.
Yes, you can share your screen, please.
Good afternoon, ma'am. I am Jatin Tiwari from the Anand Sagar University, and today I am going to present our work, real-time AI-powered intrusion detection and prevention system. Uh, and I have also my teammate joined in this meeting, Priyanshu Kumar Jha.
Yeah, hi everyone. This is Priyanshu, and thank you for having us here.
Our topic is like with the rapid growth of internet usage, cyber attacks are becoming more advanced and frequent. Traditional intrusion detection systems they rely on fixed signatures and they are fail to detect new or unknown attacks. So our work proposes a real-time AI-based intrusion detection and prevention system that detects attack and classifies them with a low latency and high accuracy. Like our problem statement is most existing IDS solutions either work offline or fail in real environments. And academic model shows good accuracy but ignore real-time deployment. This creates a like the gap that we found in our research and the real world security deployment it cannot real time it cannot classify or cannot detect the attacks. So our main objective is Our main objective of a system are real-time intrusion detection, accurate attack classification, scalability, and practical deployability using lightweight machine learning models. Our related work includes like earlier system like Snort and Zeek are signature-based and cannot detect zero-day attack. Machine learning approaches such as SVM, decision tree, and deep learning have been proposed, but most lack real-time implementation. So our main focus that we have worked upon is practical deployment, not just accuracy. So, so we have designed, we have used a data set like KDD Cup 199 from Kaggle. Actually, we have used the updated version that is NSL KDD dataset. It contains 41 network traffic features. Like the attack categories are DOS, probe, R2L, and U2R. And our model training like model train is we have how what was the structure that we have used like first of all we will the data will be fetched and then from the network Then using the label encoding will be done, and then one-hot encoding for protocol and services, and then feature scaling we will do. After that, we will adjust the data set using the handling the missing values and cleaning it, and then label mapping. Then after that, we'll classify it using binary classification and multi-class classification. We have captured the data using npcap and scapi in Windows, and we can use both this in Windows and Linux. And then the then it will, after that, it will go to the real time detection. Each packet is processed sequentially. If classified as malicious, the system further identifies the attack type, the average processing time. When we were practicing when we are applying it on real time, we got an around 8 milliseconds per attack, and making it suitable for real world use. We have used random forest and and passive aggressive classifier, because random forest is robust to noise, and it gives high accuracy and interpretability, because it combines multiple decision trees. And passive aggressive classifier we have used because it is a system, like if we are getting any data, that is if our model is predicting any wrong data, then it will change the model, and then it will try to create a new model that will help to, that will give correct answers for future. It is very useful for when it is suitable for real time and online learning. So as I said, that we are capturing the packets, like this is the structure architecture that we are using. We are capturing the packets using npcap and scapi, and then we are feature extraction. Then ml interface we are using job lib for model pipelining, and this is the our results and accuracy. For binary classification, we have accuracy of 99.1%, and for multi-class classification, we have 97.3%. And our system is also giving very low false positive. So, like when we are performing the live attacks such as UDP floods and DOS were simulated when we are testing using tools like HPing and Sloris. The system successfully detected 99% of malicious traffic with very low false positives, and the modular design simplifies integration and future expansion. However, the system currently does not handle encrypted traffic. It is a limitation of our system, and this is the opportunity that we can work for. Like it is our future work. So conclusion, I conclude to conclude, we developed a practical real-time AI-based intrusion detection system with high accuracy and low latency. Our work successfully bridges the gap between the academic research that are available and the real-world cybersecurity deployment. And we future scope we include the online incremental learning and deep packet inspection and automate firewall integration. Thank you, ma'am, for this opportunity, and I would be like to answer any questions.
Okay. Okay. Why is the real-time detection difficult, and how does proposed IDPS address these challenges?
Ma'am, real-time detection, it is difficult because, ma'am,
You are not audible.
hello,
Hmm.
ma'am, am
Now
I
you are.
audible?
Yes.
Yeah, ma'am. Ma'am, real-time intrusion detection is difficult because, ma'am, when like if we talk about analyzing in a network, ma'am, then in a network, request comes continuously. Like there is network traffic is very continuous, and to monitor it accurately and continuously, we need a model that is having a very less delay. So that is why it is like it is a very difficult task to monitor it. And ma'am, what was your second, like the alternate question?
How does proposed IDPS address these challenges?
Ma'am, IDPS, like talking about our model, as I have mentioned that we have seen a very less delay in detecting that, and uh, intrusion, like and also, ma'am, if we apply the system in real time, intrusion detection will be very helpful, because if we can identify like if we can identify on a real time any attack, then it is very much possible for any of the organization or any company to prevent it or to stop it at the firewall level itself without harming the systems.
Why is the multi-class sorry, why multi-class classification is particularly important in the intrusion detection system?
Ma'am, multi-class, because it is important, because ma'am, if because attack is not a single type, ma'am, it can be various types. So if we rely only on few trained if you rely on some models that are trained on some particular models, then particular attacks, then it is very like it's like inviting more attackers and new opportunities for them to hack and attack our system. So multi-class is important.
Okay. Over to Yashita, ma'am.
Okay, so next up we have T. Malleshwari to present
Yes.
her paper titled as Secure and Robust Face Detection and Recognition with Hash-Based Privacy Preservation. So you can share your screen, Malleshwari.
Okay, ma'am. Okay.
Mm.
The host is allowing multiple presenters sharing like that message.
I think you were present in the last session also, right?
No, ma'am.
Okay, you can share your screen.
Good evening, everyone. My name is Malishwari. Today here I am going to present my work, Secure and Robust Face Detection and Recognition with Hash-Based Privacy Preservation. Coming to the introduction, face detection and recognition are essential components of modern biometric systems and are widely used in applications such as surveillance, access control, and identity verification. With the rapid progress of deep learning, face recognition systems have achieved high accuracy even under challenging conditions. Even under challenging conditions like occlusion, such as variations in pose, occlusion, and illumination. However, despite these advancements, face detection, retina-based face detection, which provides better results. So, motivation behind this work is existing face recognition systems focus mainly on accuracy, often they ignoring privacy risks. If biometric templates are compromised, identities cannot be reissued. Hence, a secure, non-invertible, and reliable biometric system is required. The objectives are: first one, to detect multiple faces accurately in unconstrained environments, to recognize faces with high discriminative power, to preserve biometric privacy using cryptographic hashing. So here we are using SHA-256 algorithm. This is the related work. Methodology. Images are first processed using augmentation and NLM filtering to remove the noise. Later, we use retina face to detect the faces, and it extracts landmarks for alignment.
ArcFace is used for face recognition. It generates the fixed length embeddings, which are converted into secure hash codes using SHA-256. This is the methodology. In the pre-processing, we have performed our data augmentation, noise removal, and then retina face is used for face detection, key point localization, embedding generation, classifier, training softmax after saving the trained embeddings, which are given to the multi-phase detection, which detects the multiple phases in the image, and next privacy preservation. Data set and experimental setup. Experiments were conducted on the FTDB dataset, which is available in the Kaggle, which I have downloaded it from Kaggle. It contains 2,845 images and 5,171 faces. The system was implemented using Python, PyTorch, and OpenCV, an Intel i7 machine with 16 GB RAM, and NVIDIA. Results. The proposed system achieved an accuracy of 98.3, precision of 96.9, recall of 96.1, and F1 score of 91.8. These results demonstrate reliable face detection and recognition with minimal false detections. Compared with MTCNN, S3FT, and DSFT, retina face shows superior balance between speed and accuracy. These integration with ArcFace further enhances the recognition robustness. Conclusion. Coming to the conclusion, this work presents a secure and robust multi-phase recognition framework. By combining deep learning with SHA-256 hashing, the system ensures both high accuracy and storing the privacy protection, making it suitable for real-time biometric applications. Future work. Future extensions include evaluation on larger datasets such as wider face and megaface, real-time video-based recognition, and implementation of revocable biometric techniques. Thank you, ma'am.
Okay. How do evaluation metrics reflect robustness in the proposed system?
Ma'am?
Hello? Am I
Hello?
audible?
Yes, ma'am. Yes, ma'am.
How do evaluation metrics reflect robustness in the proposed system?
Here I got the accuracy of 19.83, ma'am, and precision 96.9, and recall of 96.1, ma'am. F1 score of 91.8. Previous models, they focused on accuracy, but they didn't focused on privacy, ma'am. Privacy preservation.
Okay. And why is the privacy preservation important in modern face recognition system?
If privacy preservation, why privacy preservation is important means if in traditional databases, raw biometrics are stored. If someone theft the data, then we cannot reconstruct the original data. So we are going to store, by using this proposed work, we are going to store the embeddings with the privacy preservation techniques.
Okay. Over to Ishita, ma'am.
Thank you.
Okay. So this is the last presentation for the session. So here we have with us Akshay Pujari to present his paper titled as Trans UNet Plus Plus Attention Gated Transformer UNet for Deforestation Mapping in South American Forests. So Akshay,
Yes, ma'am.
Akshay, yes, you can begin with the presentation.
Sure, ma'am. Is my screen visible, ma'am?
Yes, it is visible. You can begin.
So, good evening, everyone. Thank you for giving this opportunity for presenting our work. Our work is Trans Unit Plus Plus. It is a hybrid transformer unit for deforestation mapping in the Southern American forest. So why we have chosen this forest activities? Because we already know that forest covers the 30% of the Earth's surface and is very important for maintaining the biodiversity, and also the deforestation in the forests can affect the living animal species uh, for becoming extinct. So the existing method consists of the traditional monitoring techniques which rely on the manual surveys, which may be costly, human time consuming, and it requires more time, and also it may be prone to the errors. So our ML based system uses the semantic simulation for deforestation mapping. We utilize the hyperspectral imaging, which is the satellite images for better geospatial data and semantic segmentation analysis. So this is the motivation for this problem statement. There is a we already know Amazon rainforest is a very large forest, and in recent years it has lost 70% of this forest due to the deforestation, and also it may be the Brazilian Amazon, or it may be the Atlantic forests. Uh, and many of the Southern American forests have lost a vast number of has seen a vast number of deforestation in the recent years. So as we already know, the problem statement is design and develop an efficient deep learning system that can uh, map the deforestation using the transformer based unit. This is not a normal unit, this is the transformer based unit for better deforestation mapping and forest change detection. So finally it produces the change detection map, which categorizes each pixels into the respective classes, whether it is deforestation or not deforestation. So our objective is to pre-process the original hyperspectral images, which is in the form of HDF5 format, and we are converting the HDF5 format into a GeoTIFF format for the analysis purpose, because we cannot process the whole HDF5 format, which is sent by the satellite to the Earth surface. So we need a GeoTIFF format for further analysis, and this is the architecture of the trans unit plus plus, that is it uses heterogeneous convolution, which is better than the normal convolutions used in the unit. So and also transformer adds on the attention mechanism to this system, which helps the model to not just focus on the local features but also on the global features, which again enhances the efficiency of the model in deforestation mapping in the global context. And this is the workflow of the our proposed trans unit model. First, we are inputting the data, then we are pre-processing the data, then it is fed into the deep learning model, that is trans unit. It consists of the encoder and the decoder model, and also the vision transformers. Then the final prediction will be in the form of a segmentation map. So this is a design principle. As you all know, this is a hybrid system that is consisting of a CNN and also a transformer framework. And we also have a heterogeneous convolutions. Heterogeneous convolutions helps us for better feature extraction. Like it helps to reduce the computation while preserving the accuracy also, and also attention mechanism is very much important in this system, because previous the previous work of ours was based on the unit. So in the unit we face some of the issues in the deforestation mapping, and also uh, we again added the many other methods, but when added the transformer with the unit, it got uh, uh,
Aksar?
hello.
Yes.
Yeah, sorry, I had a network issue on my side. Sorry.
Okay.
So our previous work was based on the unit, and this time we have used the transform based unit. And next, this is a data set. So the normal image looks in this form, and the final segmentation maps looks like this. And we have three classes, that is forest, deforestation, and the other. The other may be a normal path, or it may be a river water bodies, or it may be anything. So these are the results obtained by our model. So this is the segmentation map generated by our model. So the first one is the raw image, and the second one is the ground truth, and third one is the segmentation map generated by the model. So these are the comparison of the results with the other models. Now we have different algorithms, that is unit, maybe attention unit, different unit, and last comes the trans unit. And also, I am very proud to say that another work that is based on the unit is being presented at the same conference in other session.
Hmm.
And this is the conclusion of our work. That is, it performs the outperforms the major baselines that is listed in the table, and it achieves better accuracy comparing to the other baselines. Thank you.
Okay. Explain the role of attention gates in this transunit plus.
Yes, ma'am. Like,
Explain the role of attention gates.
okay. As I already said in the previous work, we have used the unit, that is only the unit, but it only focuses on the local features. Like it is only seeing the nearby pixels for the deforestation on the or the forestation. Like when the image is fed into this model, it converts, it only checks for the each pixels, like nearby pixels. But whereas I apply that, if I apply the transform based gates, the attention mechanism, it helps for the model to understand the the similar pixels as a group, and it checks with the other group for the better context modeling. Like if I say uh, the if I say it in the form of a matrix, like A1, B1, C1, if these are the three pixels with the similar features, then it all grouped into a single cluster. So the nearby pixels which are having the same features are grouped into another cluster. So it again these attention mechanisms, they check for the nearby clusters. If they match the same features, then these are mapped into a single cluster. This helps the model for better understanding. As I already said, there are three classes, that is deforestation, and forest, and not deforestation, and other, that is water bodies. So this attention gates helps the model for whether the to map whether it is a deforestation, or it may be a water body. Like we are having a threshold for, like if the above, if the change is above this threshold, then it is called as a deforestation. Otherwise it is called as a water body. Like the previous model, that is unit, it was mapping all the other, that is water bodies, is also a deforested area. So adding this attention gate helps the model to mitigate that issue, which we already faced in the previous work.
Okay. Why is the deforestation segmentation are more challenging than the typical semantic segmentation task?
Yes, ma'am. Like in this deforestation mapping, we are not analyzing a normal RGB image. Like we have to analyze a hyperspectral image, which is very rich in geospatial data, which is having more number of bands. Like in the normal RGB image, we are having only three bands, that is red, green, and blue. But whereas sorry, a hyperspectral image has many number of bands. Like a normal typical HDF5 format, the image has a 700 MB dense in size, a single image. So it is having a very large number of bands. So in order to process this image is a very time consuming. Also, it requires a high computational power. Whereas for a RGB image, you can use a very low, uh, not large model. Model is not required for processing this image. Whereas in order to process a hyperspectral image, we need a very computationally high computational power and large models.
Okay, good.
Thank you.
Okay, so with this we come to the end of the technical session 9E, and I would like to sincerely thank all our authors for the excellent presentations and their contributions. Your work will truly reflect the spirit and quality of ICTCS. I would also like to thank all our participants for staying with us and making this session engaging and interactive. As this marks the 10th edition of ICTCS, we are deeply grateful for your continued support for not only this year but throughout all the previous editions. So we look forward to welcoming you again for the 11th edition in 2026. So a few important updates before we conclude. All presenters will receive their digital certificates within 2 working days through their emails, and the publication process will be completed within 7 to 8 months. And we request your cooperation with the ICTCS team during the publication process. Also, I would like to extend a very special thank you to our session chair, Dr. Devi Vasekar, for staying with us today.
Thank you.
And this certificate is a small token of appreciation on behalf of Team ICTCS 2025 and the Global Knowledge Research Foundation and the partners. So before we conclude this session, I will request everybody to please switch on their cameras so that I can capture this virtual moment of us together. 1 second, I'll just. Everybody, please turn on their cameras, please. Janolin, Ekta, Revati, everybody, please. Okay. Okay, thank you so much for your valuable presence, everybody, and we look forward to seeing you in the next session as well. Thank you, Dr. Vasikar. Thank you, ma'am. Thank you so much.
Thank you, Yoshita ma'am, and
Thank
thank you,
you, ma'am.
JR Foundation.